Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. Friends, YOLO11 is just arrived, and today I will share with you how you can use YOLO11 for object detection, tracking object, then vehicle speed, instant segmentation, and also we are going to create our own custom object detection model. Also we are going to create our own custom instant segmentation model for detecting custom objects. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, YOLO11 just arrived, and today we will create our own custom object detection model, also our own instant segmentation model. Also we are going to create here a counter which is basically people counter with the help of YOLO11 object detection model. So let's get started. So for that, first, this is what our repository YOLO11. I will mention the link. You need to simply copy paste the link inside the web browser, then go to the code and click on download zip, and it will download our zip format repository. As you can see, it's downloading. Done. We successfully download our repository. Just open folder, go to the downloads, and this is what our repository. Right click, WinRAR, and extract as a folder name. So this is what our folder, again same folder, and now we are inside our folder. So let's get started. So first, just open Tony Python IDE because this is complete new version, so we want to upgrade ultralytics package. So let's just first start with OpenCV, manage pack, go to the tools and then manage packages, and then OpenCV-Python. Hit enter, first package. Then as you can see, the OpenCV is basically upgraded. So OpenCV-Python is our first package. Then our main package, ultralytics, click on search on PyPy, first package. Then here you will see install button, and then after that you will see upgrade button. So just click on upgrade button and upgrade the ultralytics package. Then you can use YOLO11, otherwise there will be error. So you need to upgrade your ultralytics package. Done. Then we need cvzone package. So just run the cvzone and search on PyPy, first package, click on install button, done. It will install cvzone. That's it. So we need OpenCV-Python latest version, then we need ultralytics package, just upgrade the package, and then we need cvzone. This is how we need all these packages for YOLO11. So now we have done with package installation. So let's just start with basic object detection. So inside repository, I have mentioned the code, full code. So YOLO11 object detection and track.py. So just open with Tony Python IDE, and the basic code, if you follow my old videos, so the method is basically same which we follow for YOLOv8, YOLOv9, YOLOv10. The method is same. Only we are going to use here latest object detection model which is YOLO11. So coco.txt inside repository, I have already mentioned coco.txt file, as you can see. Then we have here, it is, as you can see. So right now I don't have GPU, so I will go with nano model which is YOLO11N. Suppose if you have a powerful GPU, you can go with YOLO11S. Then we have YOLO11L model, the large model. So simply right now I will just go with YOLO11N, which is the nano model. So first just go with real-time object detection. So I will start the camera. So cv2.video capture 0. 0 is basically the index number of our camera, USB web camera. And then we are going to resize our frame 1020 and 500, and result is equal to model.track. This is the method which we are going to use. We are going to use model.track method from ultralytics. So results is equal to model.track, and we want to pass our frame. Done. And then simply with the help of results, we are going to call the boxes, the class IDs, then track IDs, and then confidence. This is the basic method. This is the basic method, simple. And then now we have our boxes, then we have our class IDs, track IDs. Simply we are going to call all this with the help of for loop. So for box is basically our boxes, then class ID is basically class IDs, track ID is basically track IDs, and then conf is basically confidence level. And then C is equal to class name. So class name is basically our coco.txt file. Here it is. Simple. And then we are going to simply pass inside that our class ID. So class ID is basically the number for each class. Let's just say for 0 is basically for person, then 1, 2, 3, and it's continuously go on. So we are going to pass the class ID inside class names list. So when we detect the person, it will automatically choose 0 and the class name which basically assigned with 0 number. So 0 is basically for person. Simple. So if I open the coco.txt file, then you will get the idea. Here it is, as you can see. If the class ID is 0, then it will choose the person, because 0 is the person. So this is how the coco.txt label file work. Simple. So now now we have our box. So with the help of box, we will get our xy, y1, x2 and y2 coordinates for drawing the rectangle on our object. Then cv2.rectangle method, frame, we are going to draw our rectangle on the frame, and we need to pass all these 4 coordinates, which is x1, y1, x2 and y2. x1, y1 which is the top left corner, and x2, y2 is basically bottom right corner. So cv2.rectangle, then we want to draw our rectangle on the frame, then x1 and y1, then x2 and y2, 0, 2, 5, 5, 0, 2, 5, 5, 0 is basically green color, then this is the thickness 2, and then we are going to put the ID on rectangle top left corner, which is x1 and y2. Sorry, not top left corner, because a top left corner is x1 and y1. We are going to put the track ID on bottom left corner. Bottom left corner is basically x1 and y2. Here it is, as you can see, x1 and y2. You will see when we detect the object, the track ID will basically appear in bottom left corner of the rectangle. I will show you when we start our code. Then this is the rectangle size, and this is the text size of cvzone.putTextRect method. And same way we are going to put the class on detected object rectangle top left corner. So x1 and y1. So x1 and y2 is basically bottom left corner, and x1 and y1 is basically a top left corner of our detected object rectangle. Simple. So we mention our model YOLO11N. Let me save the code, and if I start the code, first it will download our latest model, which is YOLO11. As you can see, it's downloading. And then if I start, here it is, as you can see, this is basically a live object detection. It's detecting me as a person, and as I mentioned, this is basically a rectangle top left corner, and this is basically bottom left corner. So here you will see the class name of detected object. So right now the person, and here you will see the track ID, which is 1. Let me show you another object, which is a cell phone. Here it is, as you can see, the cell phone top left corner, the class name, and bottom left corner 3 is basically the tracking ID for this object. So we detected object with the help of latest YOLO11 model. So this is what our object detection. Simple. Now we are going to use here a video file. So inside that repository, I have here a video file. Let's just go with speed.mp4. So I will open first speed.mp4. So instead of 0, this is the index number of our camera. Instead of 0, we need to mention our video file. So speed.mp4, save the code and run the code. And as you can see, friends, this is what our object detection. And let me make here, we are detecting all objects. So because as I mentioned, I don't have a GPU, so I will just keep here 2 frames. then it will get a speed. Now it's good. As you can see, we have here car, truck, car. So top left corner class name truck, and bottom left corner is basically the ID of detected object. Simple. So this is how we can use YOLO11 for object detection and tracking. That's it. Now I have here one more video. So let me check the name, m.avi. So I will mention that video name over here, m.avi. Save it and just run the code. So inside this video we have basically person. So as you can see, the all person, this is basically a person which going upside. So we have only person class. There is a detection, the rectangle, and at the bottom left corner, as you can see, we have ID. So done, we have done with object detection. Now let's just run another code where we have vehicle speed detection. So let me close this code and file, open, downloads, and this is what our repository, again same folder, and inside that we have YOLO11 track and speed.py. Just open it. Again here I will use YOLO11n.pt model. As I mentioned, you can use YOLO11s.pt model. Also the model detail is basically available on Ultralytics official website. You can simply visit there and you can choose your model with your system compatibility. Simple. Then this is basically how to use YOLO11 for speed detection. So this is the model YOLO11n.pt, and then for speed detection the concept is what? When we detect our object, we have rectangle, and with the help of rectangle we will get the center point of rectangle, or we can say we will get the center point of object. So the condition is basically when the object is moving, we are going to draw there a line, and if the detected object rectangle center point touch the line, then we are going to estimate the speed. Simple. So for that we need to draw a line. So this is the line coordinates, line PTS 0288, 1019 and 288. This is the start point of line. This is the start point of line X coordinate, and this one is basically Y coordinate, and this is the end point of our line X coordinate 1019, and this is the Y coordinate. Remember one thing, for speed detection we need to mention both coordinate Y same, means this is basically start point, so we need to mention the start point Y coordinate same as our end point Y coordinate. So if I mention here 288, then I need to mention over here 288 also, then it will work. Simple. Then names is equal to model.model.names. This is how we are going to call the class names, and then speed obj. So basically if I open file, open, inside that I have mentioned speed.py. This is the class. So this is basically the code which we are going to use. So speed estimator is basically class. So if you open our YOLO11 track speed.py, so here it is. As you can see, we are calling the class from our speed.py, that's why here from speed. So speed.py is basically the code where we have speed estimator class. So from speed means from this code, and the code name is speed.py. So speed is the file name. So from speed we are going to import our class. So our class name is this. As you can see, the S is capital and E is capital. S is capital and E is capital. Simple. Then for this class we will assign a variable. So our variable name is basically speed underscore obj. Remember one thing, you can mention any variable here. This is just a simple variable. So speed underscore obj, and simply we are going to call our class, and inside that we want to pass our line coordinates. So line PTS variable, and names is equal to these names. this names variable, because this name variable is basically represent our all the class names. That's it. So for that we have these two coordinates, in not coordinates, this is basically object. So for that we have here two objects, so line PTS and the names. That's it. And then for drawing the line we need a coordinate. So how do we get the coordinates? Because we want to draw a line on our frame. So we want to know the start point xy coordinate, we want to know end point xy coordinate. So for that we need cv2.event mouse move function. So with the help of this function it is really easy to get the coordinate, because when we move our mouse cursor on the frame we will get the xy coordinate inside our shell, our bash shell. So I will show you when we start our code. That's it. And then this is our video file, and then the same things which we use inside our object detection method, same things. And then I am 0, because inside speed.py, here it is, as you can see, inside speed.py we have all the detection, we have boxes, we have class, then id, annotator, all these things. And then here we have basically estimate speed function. So inside class we have estimate speed function, and estimate speed function will return our image. If you scroll down, here it is, as you can see, it will return our I am 0. So I am 0 is basically our frame. So here we want to mention like this way, I am 0, and our variable which is we mention for the class, so speed obj. Speed obj is just a variable, so here it is, as you can see, speed obj, then dot, and then we want to mention here our function from our speed.py. So our function name is estimate speed. So here it is, as you can see, speed obj is the variable, dot estimate speed is the function from speed.py class. That's it. And then inside that, as I mentioned, inside that we want to pass our frame and then these tracks, and then we will get a class name, then we will get the rectangle, and then we will get the speed of the vehicle. So this is how the code will work. It is really easy. Now I will start the code, then we will get the result. Here it is, as you can see, when object touch the line we have speed on their top left corner 45 km/h. Here it is, as you can see, 89, then 63 truck, 78 car, 72, 83. Both side, when the rectangle, here it is, inside that we have center point, when the center point touch the line then we have the speed for vehicle. Simple. So it is really easy now to estimate, or we can say to know the speed of the vehicle with the help of YOLO11. Simple. So we have done with object detection, we know how to track the object, how to assign the ID, then we done with speed also. Means now we know that how we estimate the speed of vehicle. So I have mentioned the full code for both object detection and vehicle speed. That's it. So now let's just go with segmentation. So file open, and inside that I have mentioned YOLO11 seg track.py. Simple. So here also we have all the things are same. Then YOLO11 n-seg.pt. This is the model for segmentation, YOLO11 n-seg.pt. Then first we will go with our real-time detection, means I will mention here our USB web camera index number. So 0 is there, and then all the things are same. Result is equal to model.track frame and the true, and then we are going to call here if result boxes is not none, means if there is no object it will go with continue while loop, otherwise it will create error. That's why we mention like this way, if the result dot boxes is not none. Simple. Then boxes is equal to results boxes xy dot in cpu dot list to list. So this is the basic method which we already saw in our object detection method. This is the basic method. Simple. And then from results, here it is, as you can see, we will get the mask, because for segmentation we need a mask. So mask is equal to results dot mask, then mask is equal to mask.xy, then we will overlay the frame.copy, and then of course we will use here a for loop. So for bboxes is basically box, then track ID is basically track IDs, then class ID is basically class IDs, then mask is basically our mask. It is really easy. With the help of YOLO11, you can easily segment your object. Then this is how we will get our rectangle. X1, Y1, X2, Y2 is basically our box. So then mask is equal to mp.array mask, then np.in32, and we will reshape the mask, and then simply we are going to draw a rectangle. Then we will use the fill poly function, and then we are going to put the track ID on the frame, means on the rectangle. Then we will put the class name on the rectangle, and then we are going to create a transparency for a polygon. Simple. And then we are going to simply use c2.imshow method, and we will show our frame. I have mentioned the full code. Simple. So let's just start our code, and then it will download our model, and then we have a segmentation. As you can see, it's detecting me as a person, and there is, as I mentioned, because we mentioned here c2.add weighted method, that's why the polygon is basically transparent. And if I show the cell phone, it's detecting cell phone also. And then here it is, as you can see, at the bottom right corner there is a 4. So 4 is basically track ID, and here you will see the 1. So 1 is basically track ID. So this is how most easiest way we can create instant segmentation. Simple. So we're done with object detection, we're done with tracking method, we're done with speed estimation, and now we're done with segmentation. That's it. Now I have here, as I mentioned, we are going to create here a counter for people counting. So file open, and then YOLO11 people count. This is the project for counting the people with the help of YOLO11, which is the latest method. Simple. So this is what our basic method, and then we create a condition. If the person is detected, then only we are going to start all these things. And let me start the code. Zero. So it will freeze our frame. So here it is, as you can see, friends, our goal is to count a person frequency. So for that, with the help of YOLO11, of course we will detect the person. We have a rectangle and all these things. Also we are tracking the each object, means here we are tracking the each person. Each person, here it is, as you can see, this person we have 2 is the unique ID. So here we will draw our region of interest area with the help of polyline. For that, as I mentioned, I have mentioned the c2.event mouse move function. So here it is, as you can see, when I am moving the mouse cursor on the frame, inside shell we have xy coordinates. So let's just say I want to start from here. So xy coordinate is basically 222,121. This is what our second coordinate, 197,336. This is what our third coordinate, 803,302. This is what our fourth coordinate, means fourth one, last one coordinate, 733,115. And then I will mention all these coordinates as an area, like this way, as an area. Simple. And this area we are going to use as a polyline, c2.polyline method. And inside that we will mention np.array and the area, and np.in32 true, and this is the color. I will mention the blue color, that's why the polyline color is basically blue. So 255,000, and this is the thickness. Simple. So this is how most easy way we can select our region of interest area. Done. Now what is my condition? If the detected person center point, so this is how we will get the center point. Cx is equal to int x1 plus x2 divided by 2, we will get Cx. And Cy is equal to int y1 plus y2 divided by 2. This is how we will get our Cy. So our Cx and Cy is basically center point for each rectangle. Done. So now what is my condition? we are going to use here a cv2.pointPolygon test method, and with the help of this method we can simply mention the area. So if the person inside our area and detected object center point inside our mentioned area, then we have 1, otherwise we have -1. If the person outside area of selected region of interest, so then we have -1, and then when the person is basically inside our selected area, region of interest area, then we have only 1. So here the result, if it is 1 or -1, so we need our 1 because we are detecting the object inside our polyline area. So inside polyline area we have 1. So if the result, if it is greater than or is equal to 0, means it is 1, then we are going to draw a rectangle, then we are going to put the text, means the ID, and then because now we have unique ID for each person, so we can simply create a list, and inside that list we will append our track ID, and here when the person basically crossing our polyline area, meanwhile the ID is basically continuously counting, the same ID is again and again counting. So for that we create here a condition, if people_count.count, so people.count is basically list, here it is, as you can see, people.count is basically list. So inside that list we are basically saving each ID, detected person, each ID we are saving. So in that time we are creating the condition, please don't count same ID again and again. So for that we mention over here, if people_count.count track ID is equal to 0, means don't count same ID again and again, and then we will call the people count list as a variable p counter, and length of our list is basically number of our counter, and then I will put the counter on the frame with the help of cv2.putTextRect method. As you can see, p counter 50 60 is the coordinate, and 2 and 2 is the cv2.putTextRect rectangle method, rectangle size and the text size. That's it. So now if I start here a while loop, it will detect person only when the person inside our area, and our counter will be increased. Simple. As you can see, there is a track ID, each person we have unique track ID, and we use here YOLO official tracker, so it is perfectly working. Simple. So here it is, as you can see, we counted 27 people. When the person, if it is inside our area, then only we have detection, then only we are tracking the person, we are basically assigning the unique ID for the person. Simple. So for this project I have mentioned the full code inside YOLO11 people_count.py code. So we have done with segmentation, we create a counter, we basically estimate the speed of vehicle, then we detect the object. Now let's just start our custom object detection first. So for that, here we are going to detect, I have here Arduino Uno board, then I have here motion sensor, and then I have here ESP32. So these 3 custom object we are going to train, and we are going to create our model which detect our 3 custom object, Arduino Uno board, motion sensor and ESP32 board. So for that, first we need images. So for images we will use our USB web camera. So just go to the file, click on open, and open again our repository YOLO11 main, and inside that I have mentioned img.py code. So this img.py is basically start our web camera, and it will capture the images with the help of our USB web camera. As simple as 50 frames for each object. You can simply change the number. If you want 150, you can mention 150. For this project I will go with 50 for each class, means for Arduino class 50 images, for motion sensor class 50 images, for ESP32 class 50 images. Done. And this is the index number, and then here we want to mention the folder name. So let's just open our repository, and inside that I will create images folder. So new and images, just hit enter, and then we will save all the images inside our images folder. And then for segmentation also we need images, so I will create one new folder also, which is images1. Images1. So for segmentation, oh, there is typo mistake, let me change the name, images1. So when we create our model for segmentation, in that time also we need images, so I will save segmentation images inside images1 folder, and images folder we will save our object detection images. Simple. So images and copy as a path, and here remove the old path and we will mention our new path. From images, just go back, remove all the things, go back, done, and then press Ctrl plus V. Because we copy the path, it will paste the path, done. And then here we want to remove the double quote. That's it. Now we mention the folder which we just created, and here after images we want to mention our class name. So first I will create Arduino Uno images, so Arduino Uno. And now when we start our camera with the help of img.py code, we want to simply show the object in front of our USB web camera. We want to simply move the object in many different angle or many different way. So let me show you here. I will start the camera. So as you can see, I have moved the object in different angle. So if I open images folder, inside that images, as you can see, we have Arduino Uno images. Here it is. We have all the 50 images of our Arduino Uno board, which we are going to use for labeling purpose. Simple. This is the first image and all the way good. So now same for other class. So let's just go with ESP32. I will remove the Arduino Uno and here I will mention ESP32. ESP32. And same way save the code, and if I run the code, I need to simply show the ESP32 model. Done. So we have done with ESP32. Now motion sensor. Save the code, and same way here it is, as you can see. Done. So now if I open, this is what our images folder, and this is what our last image, motion sensor. As you can see, we have motion sensor images, then we have ESP32 images. As you can see, this is what our ESP32 board, and then we have our Arduino Uno board, Arduino Uno. So we done with data. We have now our all three classes images. So this is how, with the help of your USB web camera, you will get the live images for your custom object detection. Done. Now we need a label IMG software. We need a Python 3.8. So for Python 3.8, just open Microsoft Store, and here we will search for Python 3.8. Then just hit enter, and then search for Python 3.8. So this one. Here it is. As you can see, I have already installed. So just click on install button and it will install Python 3.8. Done. So I have already done with Python 3.8 installation process. Then we want to select inside our Thony Python ID, we want to select our Python 3.8 version. So go to the run, config interpreter, and here just click on it, and then we have basically all the Python versions options. So here you need to select the Python 3.8. Here it is, as you can see, because we install Python 3.8, so that's why there is a Python 3.8 exe option. Just select it, click on OK, and then you will see we select the Python 3.8.10 version. Now go to the tools, open system shell, and here simply, or not system shell, because you can simply install with the help of pip label img. So let's just go with tools, manage packages, and here we will search label img, label img, label img, select it, click on install, because I have already installed, so just click on install button, it will install label img software. It is really easy way. Now just open shell as already we open. Let me show you again. Go to the tools, open system shell. So we open our Thony Python IDE shell, and here we want to type our label img command. Label img, simple. Hit enter. It will open our label img software, as you can see. Now open dir, go to the downloads, our repository, images folder, and select the folder. This is what our all images. Then change save dir, same folder, images, and select folder. Done. Now create rectangle box on our Arduino Uno board. Arduino-Uno. Mention the class name. Click on OK. This is basically first image. That's why the image is basically black. Next image. This is what our perfect image. Simple. Same way, create rectangle box, draw the rectangle box on our object, means on Arduino Uno, click on OK, save it, go for next image, create rectangle box, draw it, click on OK, just save it, go for next image, create rectangle box, draw rectangle box, click on OK, and then save it. So this is how you need to select the image, means the object, and draw the rectangle box and mention the class name. So I will draw the rectangle box on Arduino Uno board, then ESP32 board, and motion sensor. So meanwhile I will pause video. So friends, we have done with Arduino Uno board. Now this is what our ESP32 board. So same way, click on create rectangle box, select the YOLO, and draw the rectangle box on ESP32 board like this way, and mention the class name ESP-32. Click on OK, click on save button, go for next image, create rectangle box, draw the rectangle box, select ESP32, click on OK, click on save, go for next image, create rectangle box, then draw rectangle box, click on OK, because we already select the ESP32, click on save, again go for next image. So this is how I will draw the rectangle box on ESP32 board. So friends, now we have our motion sensor. Same way, create rectangle box, draw the rectangle box on it, and mention the name motion sensor. As you can see, I have already mentioned motion sensor. Click on OK, click on save, go for next image, create rectangle box, draw the rectangle box, click on OK, click on save, go for next image, select the create rectangle box, draw the rectangle box, click on OK, save it. This is how I will draw the rectangle box on our last class, which is motion sensor. So friends, we have done, this is what our last image. So we successfully draw a rectangle on our three classes, Arduino Uno, ESP32, and motion sensor. Done. Now just close label img software, close all this thing, minimize the Thony Python IDE. Then just open our repository where we create our images folder, and inside that, as you can see, we have text file for all three classes and their images. Now what we are going to do, we will create here a freedom tech folder. So let's just create a new folder again and mention the name, right click and new, and the folder, and mention name freedom tech, simple freedom tech. Inside that, again just open freedom tech, and inside that again we are going to create a two new folder, images and labels. So again new folder, images, new folder, labels. Done. So we create freedom tech folder, and inside freedom tech folder we create two new folder, images and labels. Now go inside images folder, and here again we will create a two new folder, training and validation. So right click, folder, training, and new folder, again validation. Done. Same way, go back, and we're done with images. Now go inside labels folder. Here also we will create training and validation folder. Right click, new, training, right click, new, validation. Done. So we create freedom tech folder. Inside that we create labels and images folder. Then inside images folder we create validation and training folder. Also same way, inside labels we create validation and training folder. Now go back and go inside images folder. Here just press Ctrl+A, select all the data, right click, copy all the things, go back, go to the freedom tech, images, training, just paste it. Done. Go back, same way, validation, just paste it. Done. Go back, then go to the images, validation, paste it, all the data from images. Go back, same way, training, just paste it. Done. So we want to copy paste our data, images data, freedom tech, images, training and validation, freedom tech, labels, training and validation. Done. Now we will create .zip file because we want to upload this file on our Google Drive. So go back, freedom tech, right click, WinRAR, add to archive, zip, and click on OK. It will create our zip format file, freedomtech.zip. Now let me open Google Drive and then I will upload the file freedomtech.zip file on our Google Drive. So friends, I have opened my Google Drive. You need to simply open yours Google Drive. Just select new, file upload, go to the downloads, our repository YOLO11 main, and then select freedomtech.zip, click on open. Here it is, as you can see, it's now uploading. Meanwhile, we will open our Google Colab machine. So friends, I have opened Google Colab. Just select upload, click on browse, go to the downloads, repository, same folder again, and select YOLO11 object detection custom dataset, this one. Click on open. Done. We successfully upload our file. Click on not first click on connect, plus we want to select a GPU, so just go runtime, change runtime type, Python 3, select T4 GPU, click on save, and then click on connect. So friends, we successfully connected with GPU. Just run the cell one by one. First cell, click on first cell button, it will run our first cell. Then next cell where we install ultralytics package. Done. Scroll down, just import all the packages. From ultralytics import YOLO, from IPython display import display and image. So then just scroll down, and here we will cross check if YOLO11 successfully install or not, means ultralytics successfully install or not. For that we will simply download the model and we will use the image doc.jpeg from RoboFlow. So here YOLO11, just select it, YOLO11, so not V there, like this way, YOLO11s.pt, this is the model name, YOLO11s.pt, and just click on the cell. It will download YOLO11s.pt model and it will detect the object from doc.jpeg image. Done. Now if you click here on the folder icon, our result is basically saved inside runs, detect and predict to. So just select it and then predict to doc.jpeg, and then we have, as you can see, we have handbag, backpack, then dog and the person. So it means we successfully install ultralytics with YOLO11. Close just the image. Now we will mount our Google Drive. So let's just first check our upload is completed. Yes, our upload is complete. Now just click on the next cell and it will mount the Google Drive. Permit this notebook to access your Google Drive files. Just click on connect to Google Drive. Select your Gmail ID which you select for saving the file, the zip file. Click on continue. Scroll down, click on continue. Now it's mounting our Google Drive. So friends, as you can see, we successfully mount our Google Drive. Now let's just extract our freedomtech.zip. It will create dataset folder, and inside that it will extract our freedomtech.zip. So let's just run our next cell. Done. We successfully create a dataset folder, and inside that we extract the freedomtech.zip. So let me check here. Here it is, as you can see, dataset, and inside that we have our freedomtech folder, and inside that we have our images and labels. Done. So now here we want to create a data.yaml file. So freedomtech, just select it, these three dots, select it, then click on new file and mention the file name data.yaml. Data.yaml, hit enter. It will create empty data.yaml file. Just double click on data.yaml and it will open the file like this way, empty. Now open again our repository, and inside that I have mentioned data.txt file. Just open as a text editor, copy the code, copy as it is. Open the browser where we have our Google Colab, and here we have our data.yaml. Just paste it, the code from our data.txt file to data.yaml file, and here we want to mention our classes. So number of classes, we have three classes. Number of classes, we have three classes, and then first class, let's just mention Arduino Uno, then comma, single quote, ESP32, ESP-32, and then again comma, and last object which is motion sensor, motion-sensor. Done. Arduino Uno board, ESP32, and motion sensor, and number of classes 3. This is how we want to mention the class names and number of classes. Now just press Ctrl+S, save the data.yaml file, and we done. Just scroll down, and now we will start our training. So here again we want to mention our model, which is the latest model YOLO11, not V there. Remember this thing, YOLO11, not YOLO11, only YOLO11 and the yes or N, whatever model you want to select. So YOLO11s.pt and data.yml file from freedomtech folder, and the epochs 100 and image size is 640. Done. Now let's just run the code. So friends, as you can see, our training is started, so it will take some time. Meanwhile, I will pause the video. So friends, as you can see, our training is completed, and this is the class Arduino Uno, then ESP32 and motion sensor, and our model is saved inside runs detect train folder. So click on the runs, detect, train, weights, and base.pt. Just click on this three dot and download the model. So friends, we download our model, and then now go to the downloads, and this is what our model. Click on right click, cut, and move the model inside our repository YOLO11 main, and then just paste it here. Done. Now we will open our YOLO11 object detection track.py code. Just open it, and I will close the img.py, and because we change the Python version, so we want to go with again default version. So run config interpreter, and here Python 3.8, and now we will select the default one, which is Python 3.10.11. Done. So now let's just first create our coco1.txt file for custom label. So new, then there's a text document, and mention the name coco1.txt. Just open as a text editor or open as a notepad, and then we will mention the class name. So class name is like this way. So we want to open our freedomtech from Google Colab and data.yml file, and first we mention Arduino Uno, then ESP32, and then motion sensor. Or let's just, we can see here also Arduino Uno, ESP32, and motion sensor. So Arduino Uno, then esp-32, and then motion-sensor. Arduino Uno, then we have esp-32 and then motion sensor. Done. File, save, close it, and close the collab also, and minimize all these things. Done. Open Thony Python ID. So we create our coco1.txt file. So here instead of coco.txt file, we want to mention coco1. Then the model YOLO11, we want to mention best.pt. Best.pt. Done. And then because we will use our USB web camera, which is a real-time custom object detection, so simply we want to remove the video file, and we want to mention our camera index number, which is 0. Just save it, and if I run the code, and as you can see, it started our frame, and right now there is nothing. So if I show Arduino Uno, and here it is, it's detected our Arduino Uno. There is a tracking ID, bottom left corner 1, it's detected Arduino Uno, as you can see. Arduino Uno. And then we have ESP32, simple. Then we have motion sensor. Now let's just show like this way. So we are detecting motion sensor, Arduino Uno. Then we have Arduino Uno, and another hand I will pick ESP32 board. ESP, let me make like this way. As you can see, now it's detecting our Arduino Uno board, Arduino Uno and ESP32. Okay, Arduino Uno and ESP32. We create here only 50 images. Then we have again ESP32 and motion sensor. Let me make like this way. Then it will detect ESP32 and motion sensor, as you can see. So we create our own custom object detection model with the help of YOLO11 S, and it's detecting our custom objects. Done. So we have completed our custom object detection task. Now we will create a custom segmentation model. So for that, we create images1, and inside that same images I have copied from images folder. Same images, because same class which we are going to detect for custom segmentation, motion sensor, Arduino Uno board and ESP32. So I have just copy paste the images from images folder to images1. Done. So now for annotation, we will use here a RoboFlow. So let me open RoboFlow. So friends, this is what RoboFlow. You need to simply search for roboflow.com, then just sign in with your Gmail ID. So click on sign in, and sign in with your Gmail ID. I have already signed in. Then you will see this kind of dashboard. Just click on new project, and here you want to mention your project name. So let's just say YOLO11 custom, YOLO11 custom. And then annotation group, let's just mention one of our class name, which is Arduino-Uno, and then select instant segmentation. The visibility you want to select private, you can select with a public domain also. So I will select a private. Annotation group Arduino Uno, and select instant segmentation, create private project. And then here we want to select the folder, so just click on select the folder, go to the downloads, YOLO11 main, same folder again, and then we will select our images1 folder where we have all the images for segmentation. So selected images1 folder, click on upload, then click on upload. Now it will upload our images. So we successfully upload our images. Just click on save and continue. Now we upload our images. Just click on start manual labeling, then click on assign to myself, and then we're done with images. We have 150 images. Just click on start annotating. So then you will see this kind of page where we are going to start our annotation. So here I will select a bounding box tool, this one, as you can see, bounding box tool. Just select it and then draw the bounding box like this way on the Arduino Uno board. Then right click and select convert to smart polygon. Select it. As you can see, now it's converted our bounding box into polygon, and Arduino Uno is the class name which we already assigned when we created our project. In that time we mentioned the Arduino Uno, so the class name is already there. Here it is, as you can see, Arduino. Just click on save button. Go for next image. Same way, draw the bounding box, right click, click on convert to smart polygon. It will convert our bounding box into smart polygon, and Arduino Uno, click on save. Go for next image, draw the bounding box, right click, convert to smart polygon, click on save. So this is how I will draw the polygon on Arduino board. So friends, now next image, next class, ESP32. So just same way, draw the bounding box, right click, click on convert to smart polygon, and here we will create our new class. So ESP-32, and then click on create class ESP32. Just click on it, it will create our new class. Go for next image, then same way, just draw that bounding box, right click, click on convert to smart polygon, save it, and ESP32. Then go for next image, draw the bounding box, right click, convert to smart polygon, save it. This is how I will draw the polygon on ESP32 board. So friends, now our last class, which is motion sensor. Same way, select the bounding box tool and draw the bounding box on our motion sensor, right click, convert to smart polygon, and here we will create our new class, which is motion hyphen sensor. Motion hyphen sensor, like this way, motion hyphen sensor. Click on create class, it will create our motion sensor class. Go for next image, draw the bounding box, right click, convert to smart polygon. Then we already select the motion sensor class, select, just save it. Go for next image, then we will draw again bounding box, right click, convert to smart polygon, motion sensor, select it, save it. So this is how I will draw a bounding box on motion sensor also. So friends, we completed our annotation process. This is what our last image, motion sensor. Now here you will see our class motion sensor. Done. So now just click on here YOLO11 custom, which is our project name. So just click on the project name here, and then here we want to click on the add 147 images to dataset, which we just annotated. So these 3 images I just ignore it because there is a blackness on these images, as you can see. So I have just avoid all these 3 images. So we have total images 147. So just select it, click on add images, done. Then now here we want to click on just generate. Here it is, as you can see, click on just generate, click on generate. Then you will see this kind of dashboard. Scroll down, click on continue, augmentation, click on continue, create, click on continue here, click on create button. Done. Now we completed our process. Now from here we can simply click on download dataset, and we will have the zip format code, and the code we will upload on our Google Colab machine. So let me open the Google Colab machine first. So friends, I have opened Google Colab machine. First we will upload our Colab file. So click on upload, browse, go to the downloads, our repository YOLO11 main, and then we will select YOLO11 segmentation on custom dataset. So just select it, click on open, it will upload our Colab file on our Google Colab machine. So friends, we upload our Colab machine. Here click on runtime, change runtime type, select T4 GPU, select Python 3, click on save, and then click on connect. So friends, we successfully connected with GPU. So we will simply run our cell one by one. So first cell, then the next cell where we are going to install ultralytics. Done, we successfully install ultralytics. Now let's just import our packages. Scroll down, and now here we will cross check if we successfully install ultralytics or not. So here model yolo11n-seg.pt, you can select yolo11n, you can select yolo11s also. So let's just go with here yolo11n. So I have mentioned here yolo11n-seg.pt, and the image which we use over here from media.roboflow.com, same image which is doc.jpg, which we already use in custom object detection collab file. So let's just run our cell. It will download yolo11n-seg.pt model, and it will run the model on this image, and then we have detection. So person doc, so it's save, the result save inside run, segment and predict. So just click on here, just click on this folder icon, runs, segment, predict, and inside that we have our image doc.jpg. Here it is, as you can see, we have segmentation, the doc segmentation, the rectangle, and person segmentation, and the rectangle. Done. It means we successfully install ultralytics for segmentation. Now this is the code where we are going to call our RoboFlow dataset. So just go on the page here, click on download dataset, and here we want to select the format which is the latest one, YOLO11. Select it. Then just click on here we want to select show downloadable code, because we are not going to download zip format code inside our computer. We want to use the code inside our collab machine. So show downloaded code, select it and click on continue. So this is the code. So just copy it from just copy it from like this way, copy it, open collab machine, and here also from to YOLO11, just delete it, because this is the old code and we want to paste our new code which we copied, and then just press Ctrl+V. Done. Here it is, as you can see, YOLO11. Now just run the cell. Done. Now if you just click on again folder icon, again click on folder icon, we have dataset folder, because we create here dataset folder. Just select it. Inside that we have our folder, and then we have test, train and valid images. Simple. So here we want to double click on again same way data.yaml file, data.yaml, and because we train our images with the help of RoboFlow, so there is no need to mention the code. We are only going to change the path of test, train, valid folder. So here first is train folder. So just select train folder, 3 dot, copy path, go here train, and just remove the old path. Remove it and press Ctrl+V. It will paste the path. Then we have val folder, means valid. So valid, select 3 dot, click on copy path, come over here, remove the old path, Ctrl+V, paste the new path. Same for test image. Go here, select 3 dot, copy path, remove the old path, Ctrl+V, and then paste the new path. Done. Then we have 3 class, and this is what our class name, ESP32, motion sensor and Arduino. Then just press Ctrl+S. It will save our data.yaml. Now just scroll down, and now we will start our training. YOLO11, so here as you can see, here I have mentioned YOLO11. So remember one thing, this is not YOLO-V, it is only YOLO11. So here I have mentioned YOLO-V, so I need to remove this V, YOLO11-seg.pt. This is what our model name, and then I just want to select the data YAML path. So data YAML, again click on 3 dot, copy path, and from data.yml just remove all the things, remove this way, remove it, don't remove the data, and then press Ctrl+V. It will paste our new data.yml file path. Done. Then the epochs 100, image size of course 640, and then we will start our training. Just click on the cell. So friends, as you can see, our training is started, so it will take some time. Meanwhile, I will pause the video. So friends, we completed our training and our model is saved inside run, segment and train. So go to the, let's just click on this folder icon. Then we have here runs, segment, train, then weights, and inside that we have our base.pt model. So just click on this 3 dot, click on download, and it will download our base.pt model. So friends, we successfully download our model. So minimize all these things, open the file manager, go to the downloads and base.pt, right click, click on cut, YOLO11 main, again same folder. And remember one thing, because we already create our object detection model and the name is basically same, base.pt. So I have just renamed with base1.pt, our object detection model, and now I will paste here our new model which is base.pt for segmentation, base.pt, and then I will just open our segmentation code which is this one, YOLO11 seg track.py, the same code which we use for default segmentation. Here again I will select coco1.txt because we already create a coco1.txt for object detection custom label file. So same file we will use for segmentation, coco1.txt. Then here again we will mention our custom model name which is base.pt, and then cvt.video capture video file, sorry, not video file, the camera index number 0. That's it. Then all the things are good, and then if I save the code, if I run the code, and as you can see friends, it started our camera, and as you can see there is a mask, means there is a instant segmentation. And basically friends, here it is, as you can see, because for segmentation the class frequency is basically different, so it says that this is the motion sensor. So we want to check our name frequency. Let me again open the collab file, and first it is ESP32, then we have motion sensor, and then we have Arduino Uno. So we will open our coco1.txt file, and then here I will again cross check motion sensor. So first is basically motion sensor, and then we have Arduino, first is ESP32. Okay, so first here ESP32, ESP-32, and then we have motion sensor. So motion sensor is already there, and then we have Arduino Uno, Arduino-Uno. That's it. Now it's good. Click on save and just save the text file, minimize all these things, and let's just start our code again. So you have to check what is the frequency of the labels, simple. So now as you can see, it's detecting perfectly Arduino Uno. Then we have here ESP32. As I mentioned friends, we only use here 50 images for each class, simple, 50 images. In real scenario you need more images. And then this is what our motion sensor, we have here our ESP32 board, simple, and then we have our Arduino Uno board, Arduino Uno. So friends, we successfully detecting our custom object. Here it is, as you can see, the both object, Arduino Uno board and ESP32. So we successfully create our own object detection model with the help of latest object detection model which is YOLO11. So I hope you will learn something from this video. We will meet our next video. Till then, thank you, take care, and bye bye.